Hi, welcome to Math as a Language. In today's video, we're going to continue our look at functions. We've looked at functions in a few videos previous to this, but after all said and done, you really cannot overdo functions. It's really such a comprehensive, or a major part, we should say, of the mathematics and of algebra, so you really can not overdo it. However, today what we will try to do in this approach is to kind of tie three aspects of functions together, see how those elements come together, and that might be novel and new, or not, but let's take a look at it at any rate. First we're going to start with an equation. Remember, when you have a function, you have to be given a rule as to how that function is defined. So we're going to take a look at it as an equation. And then after we get the equation, we're going to go ahead and use that equation to generate a table of values. Okay, so we're going to look at a table of values, and then from that table we'll take a look at the graph. We'll take a look at the graph of the function. So, okay, a few things going on here. So let's see how these things, these aspects tie together, and it should be fun. All right. First, in terms of the equation, the rule for the function, we're going to go ahead and use a nice algebraic rule. Y equals, let's go with a negative 2x. Let's go negative 2x plus 3 perhaps. Okay, so that's our equation, that's our rule. With, of course, we know how our independent variables, the x, generate the y values. So we're going to go ahead and use, let's go ahead and put our domain elements, our x values. We'll independently choose a few values. Let's go with a 1, 0 is always nice. Let's go with a negative 1 perhaps, and perhaps 2. Okay, so any table of values. We had no reason. We just picked these guys arbitrarily. We will admit we wanted to keep them kind of small. We don't want the values to get too large, and especially since we're going to hopefully graph them later on. All right. But now we have these x values. Now, of course, the domain elements are going to generate your y values, your range values. And now at this point the question is, what are these range values going to be? Now that's where the table comes into play. We're going to use this table in order to help us generate the y values. Okay, so in terms of the table will look like this. It's kind of you do this column deal like this with a crossbar. It almost look like a inverted football goalpost, if you will, but that's neither here nor there. But you have these three columns, and the middle is a little bit wider. The first one we're going to have as our x values. We'll put our x here. Okay, and the second one we'll put head that column with a y. We'll put a y in that column. Okay, so that's our x and y values, x and y. Let's go back and let's do this just to keep it consistent. We'll make that y the same color as this guy, so we'll have it green, so because they correspond. You'll see how that works out shortly. Okay, now to make our table of values, now of course we need the rule. The rule that we put here in this middle is the rule that defines the function, and that's this guy here. So this rule goes here in the middle of the table here, and we're going to go ahead and just do that now. We're going to put our negative 2x plus 3 here. Okay, right there, that's where it goes. And now we're ready to use the values to generate some output elements. All right, let's go ahead and list these all. The x values, the domain elements, we're going to go ahead and list them there at this point. Let's go ahead with a 1, 0, negative 1, and 2. All right, now you could put them in numerical order. That's not necessary. And then we're going to go ahead and use this rule to generate the y value. See what happens when these elements, these domain elements, go into the function. All right, let's see. Well, let's go ahead and do this. We're going to go ahead and make it a negative 2. The x value is 1, so we're going to go ahead and put our 1 here. Substitute 1 in for x, so x is 1. And then, of course, our plus 3 is still there at the end to finish this off. And we're going to evaluate this. That's a negative 2 plus 3, which is 1. So y is 1. Our first output element, our first range value is 1. And we'll continue on with this. Now we're going to go ahead and do our second value. We have negative 2. X is 0, so we're going to go ahead and put our 0 in for x. Substitute 0 in here. All right, plus 3. And plus 3 and 0 is always nice. Whenever you get a chance to choose 0 for in generating domain elements, go for it because it's nice. 0 plus 3, of course, that ends up being 3. Not a bad deal. All right, one more. Let's go with the -1. Let's pick up the pace here a little bit. We're going to go ahead and have our -2, which goes here. X is 1. We're going to go ahead and put our 1 here. And oops, nope, -1. Oops, -1. Just be careful. -1 plus 3. All right, now be careful of our signs here. -2 times the -1 is +2 plus 3. That gives us a 5. All right, oops, and let's go back. We want that 5 to be in green. No big deal, but let's keep it consistent. So we'll go ahead and put our 5 there, almost there. And finally, we have x is going to be 2. So we have -2, x is also 2. We're going to go ahead and put our 2 there for x. X is 2. And then plus 3. Slightly different colors, but close enough. All right, plus 3, you get the idea. On a -4 plus 3, that ends up being -1. All right, -1. We need that in a different color. So -1. All right, good enough. All right. So we have our values, our dependent variables have been generated. Again, remember x is independent. We get to choose these guys, but once we select the x values, the domain elements, the y values, these y elements depend on what happens with the domain elements when they're inserted into the function. All right. In a previous video, we also talked about how these x and y values here can be generated as an ordered pair. So let's go ahead and do that now. So we're going to go ahead and make up our ordered pairs. Set them up like this. Remember, the x values go in the first spot, the first element, and the y is your second component. And we'll have y there. And we're going to now go ahead and generate our ordered pairs. Let's see, where can we do this? Why don't we go ahead and just do it right below here? So we have a 1. And in order to make this pick up the pace a little bit here, we'll just go ahead and stick with the 1 color. Let's go with another color we haven't used yet. Let's go with this guy. So x is a 1, 1. That's nice. So 1, 1. That's our first ordered pair. That's these two guys. And next we have 0, 3. So we have 0, 3. That's our second ordered pair. And then we have -1, 5. So we have -1 and 5. And finally, our last ordered pair is 2, -1. So we have 2, -1. Let's put that here. 2, -1. All right. So we've generated our ordered pairs. And finally, what we'd like to do now is to represent these ordered pairs, the solution set, as a graph. And we're going to go ahead and generate our Cartesian system. We have our two number lines. Essentially, they cross here. X goes there. Y is here. Let's go ahead and put our tick marks in. We have a positive direction here. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5. We'll just go ahead and number it that way so we don't have to number everything here. And then we have our positive direction. So this is our positive direction. We have our negative direction, of course, -1, -2, -3, -4, -5. And it goes on, -6 and so forth and on. That's our negative direction. Okay, it goes on indefinitely. We have our positive direction on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. Let's go ahead. 1, 2, 3, 4, 5 to keep it consistent. We'll just do them in increments of, we'll only label the units of 5. We don't have to clutter it too much here. And finally, let's go with the -5. -1, 2, 3, 4, 5. Hopefully those are only the values that we would need, and we'll go from there. So we have our number, our graph, okay, our Cartesian coordinate system, our graph, and we're going to go ahead and graph these values. All right, now let's see. We're going to make it a little bit big so we can see them. These things, sometimes it's hard to see, and we'll make it nice, bright, so we can go ahead and spot these neat quickly. So our first ordered pair is 1, 1. So we go 1 over and 1 up and put a dot there. Okay, we have it. 0, 3, 0. No back and forth movement. Just go up 3, 1, 2, 3. So that's our second point there. So 0, 3 is there. What do we need next? -1, 5. -1, 5. Back up and up 5. There we go. And finally 2, -1. 2 over and down 1. There we go. All right. So we have it done. And those are our ordered pairs, graph as dots. And so we've looked at the function a few ways at this point in time. We had the rule that we put into the table. We used our domain elements to generate the y values that go with them. Next, we represent them as ordered pairs, and finally went ahead and graphed them in a Cartesian coordinate system, okay, on a graph, in other words. Okay, now the only other thing that's new that we'll talk about here really briefly has to do with the fact that this is a function, and in terms of graphing, when you graph the points of a function, one thing you'll notice, well, there are many things you may notice, but the one thing we'd like to point out is that you'll notice that none of these ordered pairs, none of these dots are above each other, okay? And that goes back to the fact of the matter that when you have a domain element, and we're just going to go ahead and do that really quickly to review. Essentially, if we were to talk about this value right here, 1 1, you notice that that's the point right here. Okay, so that's our ordered pair for 1 1. Now, the one thing that would not make this a function is if you put in 1 into this function and the output value ends up being 4, okay, then that would be a problem, because what would happen is, if you notice, we already have 1 giving us 1. If you put in 1 and again you get 4 out, then the problem with that is you end up having 1 giving you 4 as well, and that would be a problem. You'll notice that these guys, these two values, these two dots, these 2 points would be right above each other, okay? And in math, there's an important test we would use in terms of determining whether a function, and it's simply put, it's called the vertical line test, okay? If you're dealing with a function and you're graphing it, you cannot have the one domain element giving you generating 2 different y values, 2 different output elements. Again, that would be a clear case that something's wrong, something's not working properly, and it's not functioning. So this would not be a function. Okay, if that happened. Of course, this is not the case in this problem, because that one we just made up to demonstrate the situation. According to the elements that we had, everything worked fine, and it is a function, and that's it. So thank you for visiting. We also encourage you to subscribe, and to if you have a particular topic that you want us to discuss, please indicate. Drop us a line, and perhaps we can take care of that ahead of time. So thanks for visiting. Take care, and we'll see you in the next video.